We're going to work with variable expressions today, and just to let you know, just to remind you, a numerical expression is when we have something like 2 minus 3 divided by 5. This is a numerical expression because it has numbers and operations. Obviously you know which ones the numbers are, 2, 3, and 5. The operations are subtraction and division. A variable expression is much the same thing. I'm going to put 2 minus 3 divided by 5. Oops. But if I put, instead of divided by 5, I do 5y, now we have a variable in this expression. This, y, is the variable. So, what does this y mean? Well, basically, depending on what your problem is or your situation, y, the instructions might say y is 3. Or maybe y stands for how many birds are in your backyard. So on one day it's 2 birds, but on another day it's 20 birds. So y can vary. And look at the root of this word here. That's why it's called a variable, because it can vary. It's not constantly one number. It can be a different number. So any expression that has variables and operations, it might even be x minus y. That is a variable expression. So let's take a look at an example. Let's say that you have gone in a hot air balloon. You've gone 5 miles already. We want to know what your total distance is that you're going in the hot air balloon. You've gone 5 miles already, and now you're traveling at about 6 miles per hour. So you've already gone 5, and now we're going 6 miles per hour. So how far are you going to go if, oh, by the way, t, and notice that t here is written like this, with the little tail on the end of it. That's so that you don't get it confused with a addition sign. So t stands for time in hours. So if you travel for 1 more hour, you've already gone 5 miles, and you're going to go 6 miles per hour. I'm going to put 1 in parentheses. That would mean 6 times 1. That would give you, this by the way, is a variable expression for your total distance. This would be 5 plus, what's 6 times 1? It's 6. So 5 plus 6 would be 11 miles total. If you go 2 hours at 6 miles an hour, then you'd stick a 2 in there for the variable. Order of operations says to do the 6 times 2 first, because this is multiplication. 6 times 2 is 12. So 5 plus 12 is 17. That would be your total distance. All right. So this starts to look high school level almost, but really it's not so bad. We've got a variable expression in the numerator here, right there. We've got a variable expression in the denominator, and the instructions tell us that x is 2 and y is 1. So I'm going to say that this whole thing is the same as, I'm just going to put an equal sign, it's the same as this. 3 and x is 2, so 3 times 2 minus 5 times 1 all over 2, because x here is 2, right, plus 2 times 3. Now we got to remember our order of operations. I'm going to define this for you here. So we do the top all by itself, and then it's going to, like it's in parentheses, and then we're going to do divided by this whole bottom by itself. So let's figure out what the top is first. I'm going to switch colors. Well, we do the multiplication first. 3 times 2 is 6, 5 times 1 is 5, so 6 minus 5 is 1. I'm going to put a 1 there. And on the bottom here, we have to do this 2 times 3 first. Don't do the 2 plus 2. Multiplication comes before addition. Please excuse my dear multiplication, division, Aunt Sally. Addition, subtraction is last. 2 times 3 is 6. 2 plus 6, then 2 plus 6 is 8. So this whole thing just became 1/8. Can we simplify it any further? No. That's the answer. Now, sometimes with variable expressions, we use words to describe variable expressions. So I put a little picture in here. The sum of a number and 9. We're going to use the variable n to stand for number, but it could be any letter. It could be A, B, C, D. So the sum of a number and 9 obviously means addition. Number and 9. There's the first one. The difference of a number and 21. Now this line might get confusing. It's not going to be a fraction, so I'm going to take that away. The difference of a number and 21 would be n minus 21. Okay? So we've got sum of, difference of, about to do the product of, the quotient of, and then this bottom one is just of. We'll get to that in a second. So, difference of a number and 21. The product of 6 and a number. 6, and what is product? It's a multiplication problem, so 6 and a number. Now, typically, this expression right here is the same as or equal to 6n. So typically, you'll see it like that. Put 2 of them there. That's how you'll see it more often than the left side there. The quotient of a number and of 48 and a number would be a division problem. The quotient of 48 was mentioned first, so 48 divided by n. It is not n divided by 48. That is incorrect because 48 was mentioned first and then the number. So the quotient of 48 and a number, and again, you'll typically see this like 48 divided by n. It's the same thing. That's why I put that equal sign there. Finally, 1/3 of a number. Well, 1/3 I know looks like this, and of a number. Of means multiplication. Of by itself. Okay, notice here that of is by itself. It's not product of or sum of, it's just of. So 1/3 of a number. It means 1/3 times n. Once again, instead of seeing it like this, most often you will see it like this. Just 1/3 scrunched up again up against that variable. 1/3 n. That means 1/3 times n. And remember, n is a variable. It could be whatever number they tell you it should be. So, one final problem here. If you're trying to calculate your heart rate, that's what HR stands for here. You want to know your heart rate. Heart rate is the number of beats per minute. So, in 1 minute, how many times does your heart beat? Well, if you're exercising pretty vigorously, it would beat about 150. You can even get it up to 180 beats per minute. So that would be that many beats in 1 minute. That would be beating very fast. But typically when you're just sitting here watching this video, you might be around 50 beats per minute or 60, depending on how in shape you are. So let's say you wanted to calculate your heart rate right now. You want to know how in shape you are. By the way, if you're in the 40 range, that means you probably exercise a lot. So if you wanted to calculate it, instead of actually finding your pulse and feeling your pulse and counting the number of beats for 1 minute total, sitting there for 1 minute and counting the number of beats, you could just sit there for 15 seconds and figure out, let's say you're sitting there and your heart beats about 14 times in that 15 seconds. Okay, so your heart beats about 14 times. Well, you're going to take 15 times 4 gets you to 60, doesn't it? And so we want to know however many beats you have in 1 minute. So we got to do 4 times the number of beats you counted in 15 seconds. So we're going to assume that you're sitting there, you counted 14 beats in 15 seconds, and we're going to assume your heart rate, that the next 15 seconds would also be 14 beats, and the next 15 seconds would be 14 beats, and the next 4 times would get you to 60 seconds. And what is 4 times 14? Well, 4 times 14, we can do that in our head. 4 times 10 is 40. 4 times 4 is 16. 40 plus 16 is 56. That would be your heart rate. There we go. That was variable expressions. This even right here is a variable expression because there are variables and there's operations. What operation is in here? Well, you can't see it because we didn't write it, but there is a multiplication sitting right in there, isn't there?